Alright everybody, so today we're going to be going over proportional versus non-proportional, and we're going to look at this through a graphing eyes, okay? So how do you graph proportional versus how you graph non-proportional, okay? First thing that we're going to introduce you guys to, which you guys seem to not know yesterday, is a very important equation. Slope-intercept form. Does anybody know what slope-intercept form is? Remember it from yesterday? It's not y equals kx. It is y equals mx plus b. So it's y equals mx plus b. Okay. Let's find out what everything stands for. This is the most important part of the equation. M represents your slope. So M, guys, represents your slope. Now it's nice to know what that M represents slope, but we also need to know what slope is. Does anybody know what slope is? What do you think it is, Hunman?
Oh, it's like the line that goes through the line.
No, that's just your line.
It's like the line that
A slope, guys, a good way to look at slope is it's a change in the y direction. That means how much you go up or down over a change in the x direction, which means how much you go to the left or right. So change in y is whether you go up or down. Change in x is whether you go to the left or right. So all of that is slope. That's what slope is. And then we also have b. Does anybody know what b stands for? It's your y-intercept. Very good. B is your y-intercept. And it's basically where your line crosses your y-axis. Okay, so it's where the line crosses the y-axis. Right? Those are the only things I'm going to go over right now. There's two other parts, which is your y and your x, and yes, they are important also, but we're going to get to those eventually. For now, they're just y and x, okay? Once we start doing functions, then we'll introduce input, outputs, all that good stuff. For now, just if you know your slope and you know your y-intercept, I'm happy for now. Everybody okay for that?
Yeah.
Okay, so we're going to start off with proportional. Proportional relationships. And their graphs. Okay, so I know last year, whenever you guys did proportional relationships, you were given tables, right? And you had to check whether it was proportional, right? So let's start off with the table. Let's go with I don't know. Let's just go with x and y. Uh, 2, 4, 3, 6, 4, 8, 5, 10, 6, 12, and we'll just stop there. Does this represent a proportional relationship, guys? So I guess my question is this proportional? How do we know? How do we check for proportional relationships? You need a pattern, but what did you guys call it? A constant of what? Constant of proportionality, right? And your constant of proportionality was k equals y over what? K equals y over x. And you always needed to have that, right? Only we're not going to use k anymore. We're going to use what? We're going to use m to represent our slope. Okay? So let's look. What's up, dude? Yes, please. So we are going to go with the first one. So 4 over 2. What is the constant of proportionality there?
2.
That's 2, right? What about 6 over 3?
2.
Is also 2, right? What about the next one? Let me color code these for you guys. What about the next one? What would that be? Would that be 4 over 8 or 8 over 4?
8 over 4.
8 over 4. Y over x, very good. And that is what?
2.
2. Now let's go back to 5 over 10. Is it 5 over 10 or 10 over 5?
10 over 5.
Which is 2. And then 12 over 6, which is what? So is this proportional?
Yes.
Because what? So yes, this is proportional. And for now, I'm going to call it a constant of proportionality, but I'm going to stop calling that as we get deeper into this, okay? After a while, I'm just going to call it slope. So yes, because we have a constant of what?
Proportionality.
Constant of proportionality. Also known as a what? Which is what? What is our constant of proportionality?
2.
Which is 2. Everybody okay with that?
Yeah.
Okay. Now, yes, you have your table, but these also represent what? These are coordinates, aren't they? Can you guys graph the coordinates, please? So, yep, you have to make a graph. You can use graph paper if you have some. Okay, so let's graph all these points. Okay, let me fix my graph. It's a little bit off. Let's move this guy there. All right, guys, so what's my first point? I'm going to call my first point, let's call it A. This is point A. That means I go over how many?
2.
Go over 2 and up how much? So there's point A. What about point B? Where can I find point B?
You have to go over 3 and then up 6.
Now, here's my question. Do I go 3 from A or do I go 3 from the origin? From the origin. So I'm going to go over 3 and up 6. What about C? That's over what? Come on, guys. Over how much? Over 4 and up? 8. And let's do one more. D is over 5 and up 10. Now I can draw a line to connect all of these. So I'm going to do that. Now I want you to see what's actually going on here. What did we say was our constant of proportionality? 2. Now look at our slope. We went up how much? 2 and over. So our slope is again what? 2, right? Can we do the same thing the other way? If I go down 2, that's negative 2, and to the left 2, that's negative 1. What's a negative over a negative? It's also a positive. So that's also 2, right? So I want you to pay attention to this. What's your y-intercept? What's your y-intercept? The y-intercept is 0. So my y-intercept is, I'll put it in, let's use orange. Oh no, let's use like a light green. This is my y-intercept right there. That's my y-intercept. And the point is 0, 0. And what kind of graph is this? This is a what? This is proportional. Is everybody okay with that?
Yes.
Yeah? Can we keep going? Is anybody still copying this?
Yeah.
Someone's still copying this? Okay. Hey, your hand's good again. Good so far? Okay. So I'm going to keep it on there because there's one thing I want to go over also. What is the equation for this graph? Do you guys know how to get the equation of this graph? Raise your hand if you have an idea. Raise your hand if you have no clue. Okay? So to get the equation from this is a linear graph, right? So all linear graphs can be written like this: y equals mx plus b. The only two things that you have to fill out is your slope and your y-intercept. Do we know what those two things are?
Yeah.
So what is the equation? Y equals,
2x. 2x equals 0.
that's it, guys. That is your equation of the line. Yes?
Will we have homework where we have to like make this graph and then write it in an equation, or will it just be the graph?
Maybe both. Okay. Everybody okay with this so far?
Yes.
Okay. Let's try another one. Go ahead, guys. Just like we did on the previous one. Give you guys about 4 minutes. JQ. Guys have about a minute left. Check with the person next to you, make sure that you guys are doing the same things. Is it proportional or not? Oh, you did it. Alright, yes.
Decimals can be proportional too, right?
Huh?
Decimals can be proportional.
Decimals can be proportional also. Okay. So, is this proportional?
Yeah.
How do I know?
The slope makes a line through the
It goes to the origin and also what? What is my constant of proportionality? K is 3, right? Okay. If I do 3 divided by 1, well, that equals 3. So I can do another one over here where this is K, or Y over X. Then this is also 3, this is also 3, this is also 3. Okay, so this is proportional, and I like what Lucas said. Lucas, how did you tell that this was proportional? It goes through the origin. I'm glad that you noticed that. Did anybody else notice that?
Yeah.
If your line goes through the origin, it'll be proportional. If it doesn't go through the origin, then it's going to be what? Non-proportional. That's simple, guys. That's simple. If a line goes through the origin, it will be proportional. But you're not always given an equation. Sometimes you're just given a table, and the only way to check for proportionality is if you have a constant of proportionality. Does that make sense? Okay, so let's graph this thing. First one tells me to go over 1 and up what?
3.
Then the next one over 2 and up 6. And next one over 3 and up 9, right? Somewhere over here. So That's as far as I'm going to go because I'm running out of room. So when I graph this, there is my y-intercept down there. And just like you guys said, it goes through the origin. So my y-intercept is 0, 0. To create the equation of this line, this is linear, right? So it's going to be in the form of y equals not
X plus B.
plus b. The only things that I need to substitute in for are m and what's m? It's our constant of proportionality, right? Or you can check it over here. It's your rise, change in y, which is 3, over our run, change in x, which is 1. So 3x plus what?
0.
Plus 0. Everybody okay with that?
Yes.
Okay. What time is this class over?
It ends in around,
We got
36.
36? Okay. We got about 8 minutes. So we're not going to get to non-proportional today, but that is part of your homework. Okay, so on the homework, when you get to the non-proportional parts, do the best you can. Okay, we'll cover those tomorrow. Remember, you guys still have Friday to do it. Okay, so I want you to graph the following. Don't let this confuse you guys. Just remember, there's only two things that matter here. That represents your what? Also known as your slope. And this represents your what? So if I wanted to graph this, what is my y-intercept? So it starts at the origin. And then my slope tells me, what is my slope first of all? 2/3. So it tells me to go up how many? And to the right how many? I can do that again. Up 2 more. And to the right 3 more. I can do that again if I wanted to. Up 2 more. And to the right 3 more. See how simple that is, guys. And if I look at this, from one point to another, what do you guys think the slope is going to be? 2 over what? Up 2 and to the right 3. And that's going to be everywhere. Now I want you to pay attention to something kind of curious. If I went from this point, I'm going to erase this one for now. If I went from here, and I skipped 1 point, and I went to the other point, I wouldn't get 2 over 3 anymore. I would go up 4, and to the right 6. How is that still proportional then? 4 over 6 is the same as 2 over 3. It's just a reduced version of it. Does that make sense, everybody? Okay. Okay. Are we okay with that one? Okay. Okay, so now that you guys did that one, I want you to graph another one. Let's give you a non-proportional one. What is this, example 4? How do we know right off the bat that this is non-proportional, besides the fact that I said non-proportional? Y-intercept is -4. Proportional would mean the y-intercept would be what? 0. So if I wanted to graph this, I start at what? 1, 2, 3, 4. And then what is my slope? So what do? I go up 2, and that's it? So Miguel's saying that I go up 2 and to the right 2. But if I did that, then my slope would be 1. My slope is not 1. My slope is 2.
You have to go up.
Oh, go to the right once and
To the right once. Very good. So what I like to do is when I'm given a whole number, I'll write it as a fraction. That way I can see my rise and my run. My change in y and my change in x. So I'm going to go up how many? 2 and to the right once. I can do that again. Up 2 and to the right once. Up 2 and to the right once.
it's not proportional.
And that's not proportional, but this is still linear. Okay, just because it's not proportional doesn't mean it's not linear.
It's still
Okay.
a line.
It's still a line. Very good. Okay, is that okay, guys?
Yes.
All right.